Hi, in this video, we're going to talk about stateful DHCPv6. Okay, so we're going to look at method 3, where all addressing information except the default gateway address, which cannot be obtained from any DHCPv6 server, only the router advertisement, but everything else will be received or obtained from a stateful DHCPv6 server. Again, all begins with the router advertisement message. In this case, we've set the M flag to 1. So the client says, I'm only going to use the source address of the router advertisement as my default gateway. I'll get everything else from a stateful DHCPv6 server. Okay. And there's the message exchange there. Okay, so setting the M flag to 1. So we do that with the IPv6 ND managed config flag. Putting a no in front of that will turn it back to, set it back to 0. The O flag is ignored at this point with the M flag set to 1. Okay. All right, now if we have a Windows host, although we've set the M flag to 1, if the A flag remains at 1, the Windows host will see that and say, okay, I'll get one address from a stateful DHCPv6 server and another address from, I'll create my own address using Slack. So with the A flag set to 1, it will create its own address using Slack. And then we'll have another address that it received from the DHCPv6 server. Okay, that's usually not what we want when we want to use stateful DHCPv6. Let me show you why. Because what happens is, in red here is the address that it received from the stateful DHCPv6 server. That is typically what we want, because we want, usually as a network administrator, to be able to manage the addresses and know who has what address, so we can monitor in case we need to monitor it, or for security reasons, or for whatever reasons. We need to know who in our organization has what IPv6 address. But we can see that it also created an address using Slack. And because Windows uses the privacy extension, it created another address called that temporary address. For when it establishes a connection, it will use the temporary address. So we have 3 global unicast addresses. All right, well, we don't want the privacy address and we don't want this other Slack address, obviously. We just want the one address from the DHCPv6 server on these clients. Okay. So there's some information on this. So some people think, well, why not just disable the router advertisement message? If our client, let's say the operating system, can do this without a router advertisement, it's going to talk to the DHCPv6 server, can we just disable the router advertisement? Well, first of all, the router advertisement is usually what informs the operating system, or does suggest to the operating system how it should obtain its addressing information. But let's say the operating system was written, or there's a feature that says, I have a button that says use DHCPv6. Well, we still need that router advertisement message. First of all, remember, the host, the end device, can only get its default gateway address from the source address of the router advertisement message. Okay? Without it, the host won't be able to communicate off of its link. The other thing is that in the router advertisement message is that L flag, that on-link flag, and a prefix. So the prefix in the router advertisement with the L flag tells the device, hey, this is the network you are on. DHCP is not, it can get an address from a stateful DHCPv6 server, but it doesn't know whether that address is on its link or not. That's something different than with IPv4. Devices can actually receive an address that is a member of another subnet, which means it has to send everything to the router. Anyway, you don't want to be disabling the router advertisement message unless you really know what you're doing and have a real specific reason to do so. Okay, so the solution to our problem is just set the A flag to 0. And we can either do that by saying IPv6 ND prefix and give the prefix that's in the router advertisement and the prefix length and say no autoconfig. Or we can just say IPv6 ND prefix default no autoconfig. That says for all my prefixes, if there happens to be more than one that I'm advertising on this link, set the A flag to 0. Okay, that will then tell the host not to use Slack. All right. So let's take a look at our stateful DHCPv6 router advertisement. It's going to all IPv6 devices, sent from the link local address. There's our prefix length, manage config flag set to 1. The end device will receive this router advertisement and says, okay, it came from that link local address. That's my default gateway. Manage config flag set to 1. That means I have to talk to a stateful DHCPv6 server, which I will do to get all my addressing needs. And because the A flag is set to 0, I will not create my own IPv6 address. I will go to a stateful DHCPv6 server for everything but the default gateway address. Okay, so here's the commands, and we've kind of seen this in the previous. Everything's kind of the same as the stateless DHCPv6, except for one thing that I'm going to point out. A couple of things, actually. This command here, this is what makes this pool, whatever the pool name is, stateful, is this command right here. Okay, also notice that we've set the manage config flag to 1. And the A flag, we're going to set that to 0. And we're going to associate this interface, say, oh, by the way, I'm also acting as a stateful DHCPv6 server on this interface. So the router's going to send out the router advertisement and also act as a stateful DHCPv6 server. Excuse me. So let's take a look here. Okay, this command sends out the router advertisement message. Okay, we've got the M flag set to 1 and the A flag set to 0. Okay. We also want this router to act as a stateful DHCPv6 server. Okay. Oh, let's see. Yeah, so I actually am showing both commands here. IPv6 and default, no autoconfig, or you can use this one. You wouldn't want to, you don't need to do both here, right? Okay, one or the other, but I'm showing both. Okay, so we want this router to also act as a DHCPv6 server. So when a client sends out that solicit message, we say, hey, guess what? We are a DHCPv6 server. So when the router receives that solicit message on this interface, it knows that it's a stateful DHCPv6 server. Sorry, that's my reminder for something. So the one big difference here, okay, that's the A flag again, is this right here, the address prefix. This is what says I'm going to allocate addresses to you. Now in IPv4, when we send up a DHCPv4 server on a router, we'd say which addresses we want to exclude. In IPv6, we don't do that. We actually say everything is included by default. So I could use, you notice here, back up here, I used /80 instead of /66. So this is the prefix devices will be getting. Now I could have left it at /64. Let me show you in a moment here. I could have left this as a /64. no real danger in that, except with a /64, you're allocating anything from all zeros to all ones in the host. It is possible that we could have a duplicate of something that has, if we configure static addresses on servers and routers and things like that, that there could be a conflict. But very doubtful with 18 quintillion possibilities. However, what I like to do is say the addresses that are going to be allocated are going to have this first 80 bits. And this way, I put deed in here. That way, whenever I see deed, I know that's an address that's been allocated by a stateful DHCPv6 server. So everything allocated will have deed as the first 16 bits of the interface ID. This is actually pretty cool. And it's the only addresses that we allocated by this DHCPv6 server. So when we look at our client, we see here, yeah, see this deed here? That tells me that is an address that came from that stateful DHCPv6 server. Okay. So the only thing received from the routing advertisement was the default gateway. Now also the prefix and the on-link flag. Okay. But this address here was received from the stateful DHCPv6 server, and so was this information here, the DNS server and the domain name. Okay, we can verify that the router is acting, which flags are set, and by seeing right here, hosts use DHCP to obtain a routable address. Notice it doesn't say other information or anything about Slack. It says my M flag is set to 1. So informing host to use stateful DHCPv6. And we can actually see this when we do debug IPv6 ND. This says this is a debug, and it's showing the router advertisement being sent. The managed config flag is set. The L flag is set, but there's no A flag here. When we looked at Slack, remember it was LA, meaning the A flag is set. It says this is the prefix that I'm telling you is on link. So when you receive that address from the DHCPv6 server with this first 64 bits, it's on link. Any other devices, any package you need to send to a device with this prefix, it does not need to go through the default gateway. You can reach it directly. Okay, looking at the router advertisement message in Wireshark, we see the M flag set to 1, the O flag set to 0. We see the on-link flag set to 1, and there's our prefix. And the A flag set to 0. Now, this prefix isn't going to be used for Slack because the A flag is set to 0, but it is saying you are on link to this prefix. Okay. Looking at my WinPC, very cool. I can see that it has an IPv6 address. Look, least obtained, least expired. Here's my IAID, my DUID, but I can easily see with deed here in the first 16 bits of the interface ID, this address was obtained via stateful DHCPv6. Okay. I can then take a look at my pool information, stateful DHCPv6. In this case, I have rapid commit disabled. I can also see that the addresses have been allocated. We've had one active client show IPv6 DHCP pool. Tells me what prefix I'm allocating with the first 16 bits of the interface ID as deed. This is kind of cool. Okay, I can see, yes, when I do show IPv6 DHCP binding, I can see that I have allocated this address, and there's the WinPC's address. I can see that I also get the link local address from the client and its DUID information. Very cool. So I can see this is the binding. This shows what addresses this router acting as a stateful DHCPv6 server has allocated and to who. I'm a stateful server. This device with this DUID has been allocated this address by me. I'm containing state information on that device. Okay, and a router, by the way, can act as both a stateless and a stateful DHCPv6 server, just on different interfaces. So this is kind of showing a combination of this router acting as a stateless server on one interface and a stateful server on another. Okay, and that's stateful DHCPv6.